Oh, focus. All right, here's that surprise that I promised you guys. School finally gave me a webcam, so now you can see my pretty little face during your videos. Still trying to figure some stuff out, but I figured that since today was a shorter lesson, we could do a throwback to the good old whiteboard days, and then you could just be entertained with me. All right, so as you see, Vanna White right here, today we're going to talk about the derivative of inverse functions. We spent a lot of time reviewing inverse functions when we started off. Remember, inverse is when the domain and the range switch. All right, I'll put that in the little tiny letters just because I shouldn't have to talk about it. We should remember this. Focus. Okay. So if we have our normal function f of x, like I said, tiny because we should know this, and it has a domain and a range. When we go to f inverse of x, that's our inverse function, and that has a domain and a range. Well, the domain of our original function is now the range of our inverse, and the range of our original function is now the domain of our inverse. All right, hopefully we all remember that. If you need help with it, come see me after school, and we shall talk about it. But when we focus on just the calculus part of functions and their inverses, what color do I want? I'll use black. Okay. Something that we know is stuff about continuity, all right? Hopefully you all are good with continuity because it's on your quiz tomorrow. All right, so for starters, if our original function f of x is continuous, all right, if our original f of x is continuous, then this implies that our inverse is continuous. All right, very good multiple choice question for something. How do you know that an inverse is continuous? You'd know that if the original is continuous. Okay, and since continuity implies differentiability, continuity doesn't always imply differentiability. However, comma, I do know that if f of x is differentiable, then you guys are just going to have to trust me that that also means that f inverse of x is also differentiable. All right, and like I said, you guys have to trust me because continuity does not imply differentiability. Okay, think of absolute values. If you look at an absolute value graph, yes, it's continuous, but because it has a cusp, it's not differentiable at that cusp. Okay, so continuity does not always imply differentiability. Okay, and then the only bad part of this is that I don't have a whole lot of room to work with. All right, but hopefully you guys have copied this all down. The important part of this is actually when we start taking the derivative of an inverse. All right, because that's what the title of the lesson is. Meow. Okay, just trying to get it to focus a little better. So I'm going to erase this. So when we actually take the derivative of an inverse, there actually isn't a way, like a nicer way to write this. This is actually f inverse of x prime. Should probably put that in parentheses. All right, f inverse prime of x. Okay, this is the symbol for inverse. Then we're taking the derivative of the inverse. All right, the nice formula for this is that this is going to be 1 over f prime of f inverse of x. Okay, so this is something that you guys should put on your formula sheet because this is something that you guys need to know. It's so important, I'll box it in the best color ever, purple. Okay, so the derivative of the inverse, so f inverse prime, is equal to 1 over f prime of f inverse. To me, the trick for remembering this is since the derivative's on the outside, the derivative is on the outside. The inverse is on the inside, the inverse is on the inside. Okay? So that's how I remember it, but you really just got to know this formula. Okay? And I will do an example. This is not an example from your book. This is one that I just have all on my own. And let's do find f inverse prime of x and then for my original function, how about we do f of x is equal to negative 3x plus 3. Alrighty. So I know that from this formula that I need to do f prime of f inverse of x. So the first thing that I should probably find out is what is f inverse. So this is when you need to remember how to find the inverse of a function. I'll do that in red. So we have f of x is equal to negative 3x plus 3. That's in function notation. If we switch to explicit notation, that means that this is y equals. When I find the inverse function, my domain and my range switch. So we're going to change this to x is equal to negative 3y plus 3. And I need to solve for y because that's going to give me my inverse function. So I can subtract 3. So I get x minus 3. And then I'll divide by negative 3. And that'll give me my y. Tilt down a little bit. Whoops. There we go. Okay, and so this is my inverse function right here. So that's going to be my inverse function. And I don't know why the lighting's going all weird. So I really could write this as f inverse of x is equal to x minus 3 divided by negative 3. Bueno. But I also need to find f prime because whatever I find out, so now I have my f inverse of x, that's this right here. And my definition says that I'm going to take f inverse of x and I'm going to plug it in to f prime of x. So I should probably know what f prime of x is. So when I find, I shouldn't use purple because then it's going to look the same. I'll use black. When I find f prime of x, that's just the normal derivative, and that's just going to get me negative 3. That was lame. Alright, that is just going to give me negative 3. So now when I want to find f inverse prime of x, I've got room right here, I can do that. So f inverse prime is equal to 1 over, and I'm going to do f prime of f inverse of x. Well, f inverse is what I found down here. That's x minus 3 over negative 3. And then when I evaluate 1 over f prime of this, well, f prime of this, that's kind of lame. It's just negative 3. It doesn't matter what I have in here. So the answer is just 1 over negative 3. Done. Okay. So kind of a pain because you do actually have to go through the process of finding the inverse of f, and then you have to find the derivative of f, and then you have to plug all this in and evaluate. And of course, it's not always going to be nice where it's just a constant, you're not really doing anything. Okay, so how about I do one more example? I think I haven't been talking too long. Okay, so I'm going to erase this. If you need more time, pause it. All right, I'm actually going to erase all this just so I can go a little more vertical. All right, but I am, and this is a good habit for you guys to get into. If there's ever something that's kind of lengthy to remember, get in the habit of writing it on the top of your homework page or your test page. So even though I erased that, I'm going to rewrite the definition of the derivative of an inverse. So I've got f inverse, as you can see I'm putting it way up here, f inverse prime of x is equal to 1 over f prime of f inverse of x. Prime's on the outside, prime's on the outside. Tilt it a little bit, there you go. And I will do one more example. All right, so find f inverse prime when f of x is equal to, how about the square root of negative 2x minus 3. Okay, this one's a little trickier. It's got square roots in it. Okay. So first off, I should probably know the inverse of my function. I need my glasses on or else I can't see this. So, and I will do that in green. All right, now I'm going to find my inverse. So if I look and I write this in explicit notation, that means I have y equals the square root of negative 2x minus 3. I have to flip them because I'm finding my inverse. So x is equal to the square root of negative 2y minus 3. I'm trying to get y alone, so I should probably get rid of that square root. So I'm going to square both sides. So I get x squared is equal to negative 2y minus 3. Woo! I saw that. That was weird. Add 3 to both sides. X squared plus 3 is equal to negative 2y. And then divide everything by negative 2. So this is negative 1/2 x squared minus 3/2 is equal to y. So this is my inverse function. Okay. Now that I have my inverse function, I got to find out what I'm plugging that into, right? So I need to find my derivative. How about I do that in red? Christmas colors, anybody? So when I find my derivative, all right, remember that this is really negative 2x minus 3 to the 1/2 power. So then I can rewrite this, or I can take the derivative using my power rule, so I get that f prime of x is equal to 1/2 times negative 2 minus 3 to the negative 1/2 power, you gotta subtract 1, times the derivative of the junk, which is negative 2. Don't forget to take the derivative of the junk. I'm serious. All right, and then I can simplify this because this 2 and this 2 is going to cancel, and I'm going to be left with negative 1 over the square root of negative 2x minus 3. Woo! So now I can just plug stuff in. So when I find f inverse prime, not to be confused with Optimus Prime, this is going to be 1 over, and I'm going to do f prime of f inverse. Well, what is f inverse? That's this mess over here. It's negative 1/2 x squared minus 3/2. Then I have to take this, and I have to plug this into my derivative, which we just found out right here. So this is equal to 1 over negative 1 divided by the square root of negative 2, and this is going to be negative 1/2 x squared minus 3/2, all under that square root. I'm writing slanted, I'm sorry. Okay, but this is actually going to clean up really nicely, because when we distribute this 2 to everything, this is really 1 divided by negative 1 divided by the square root of x squared plus 3, right? And then, jump over here, dividing by a number is the same thing as multiplying by the reciprocal. So 1 divided by this is the same thing as if I did 1 times, and then this is going to be the square root of x squared plus 3 divided by -1, which is really silly because anything divided by -1 is just negative. So that right there is your answer. Okay? So that one was a little more funky because when you took the derivative, it wasn't just a constant because it wasn't just linear. Okay, but not too bad. Just some algebra skills and it cleaned up pretty nicely. Okay, so I'm going to erase this. If you need more time, hit pause. Okay, and that's really all I got right now. So those are the 2 examples. Make sure that you guys are studying for your quiz. Oh, one more thing. I think I started, where did I start? This starts on page 177 in your book. All right, if you flip over, I think it's page 179. It actually gives you some new derivatives for you guys to remember. Okay, because what we just did were examples of normal functions. But we also have inverses of trig functions. All right, so we also need to know how to find the derivative of inverse trig functions. There are proofs to them. You're more than welcome to look at them because they're in the book. However, I really just want you guys to memorize these. You need to memorize them because you need them. All right, they are not going to be on any CISC quizzes this week. They will not be on your quiz tomorrow, but starting next week, they are fair game, okay? So you do need to know these. And I'll write them down real quick, and that'll be the last thing I do, but they are in your book on the next page after what I did. I don't know why this video is freaking out. Focus, focus, focus. It's getting there. It'll work out. All right, maybe it's just because I'm not writing. Maybe the video wants me to do math. So, look at that. All right, so derivatives of inverse trig. All right, and if you're looking in your book, it uses the arc notation. For instance, instead of sine to the -1 power, it writes the derivative of arc sine. I personally don't care which one you use, but you need to know that they both mean the same thing. Okay, so the derivative with respect to x of inverse sine of x, this is going to be equal to x all over the square root of 1 minus x squared. Yeah, that's messy. I don't know what to tell you. Sorry. Okay, so that's what it is for inverse sine. And then remember, cos are negative. So that rule kind of always implies. So if the derivative of sine is this, then the derivative of inverse cosine is negative this. All right, so kind of keeping with that cos or negative thing, if you remember sine, then cosine is just negative. On the flip side, if we know that the derivative of inverse tangent, whoops, that's just a D. All right, the derivative of inverse tangent, that is equal to x over 1 plus x squared. Then, since the cos are negative, we know that the derivative with respect to x of inverse cotangent, that's just going to be equal to negative x all over 1 plus x squared. Okay. And I'm running out of room. I'll write it really tiny over here. the derivative of secant, inverse secant, sorry, that is equal to x over the absolute value of x times the square root of x squared minus 1. That one's kind of messy. All right, actually, I don't think you guys can see that too well, so I'm going to write it up here. All right, sorry. So the derivative of inverse secant, that is equal to x divided by the absolute value of x times the square root of x squared minus 1. Kind of messy, I'm sorry. All right, but since the co's are negative, we know that the derivative with respect to x of inverse cosecant is equal to negative this. So negative x divided by the absolute value of x times x squared minus 1. Ooh. Okay, and that's it. So these are actually on that formula sheet I gave you, but this is also something that you need to know yourself. Like I said, if you remember the originals, we know that the co's are negative. The only little tidbit that I can give you to help remembering these is that for me, I think tangents have plus signs because plus signs look like T's. And the tangents, they're weird because they have a plus sign and because they don't have a square root. So that's how I remember tangent. Tangent is plus because it looks like a T and there's no square root. And then for secant and cosecant, it switches the order. So here it has 1 minus x squared. Here it's got x squared minus 1. And then the whole absolute value thing is just kind of funky. So that's all I got. Study for your quiz tomorrow. Your homework is that limit continuity review packet. Make sure you do the quiz after this, and hopefully you like to see my face. All right, bye guys.